Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Today our group, which is Azri and Nur Asyikah, we're going to present ISMAIL impact test. So the objective of the experiment is to find the impact resistance of mild steel and cast iron. The apparatus used in this experiment is impact testing machine. So for the first step, we should choose the ISMAIL test specimen. So I will choose cast iron. So the length of this cast iron is 76.4, the breadth is 9.4, depth is 9.16, and depth of notch D is 2. So the second step is to test for friction loss is conducted by adjusting the pointer to 164 joules. The pendulum is released by operating the lever without keeping the specimen. So the loss of energy due to friction is 2J. Step 3 is the ISMAIL test specimen as per Indian standard IS 3766-1977 is placed in position. So here we will see radius of curvature of striking edge, and then test piece, striking edge, angle of tip of striker, direction of impact, angle between the underside of striker and face of test piece, and then lastly is support. Step 4 is the pendulum is released. The hammer strike against the specimen, breaks it and swing further than observation is noted down. So here we will see that we got total loss of energy during transit of hammer ET is 4J, and energy for failure of specimen is ET minus EF equals to 2J. So here are the observation that I've just read just now. So step 3 is the ISMAIL test specimen as per Indian standard 3766 minus 1977 is placed in position. Selected specimen is cast iron, length in 75, breadth 9.3, depth is 9.4, and depth of notch D is 4.2. Step 4 is the pendulum is released. The hammer strike against the specimen, break it and swing further than the observation is noted down. So here we will see that total loss of energy during transit of hammer ET is 6 joule, and energy for failure of specimen is ET minus EF equals to 4J. So this is what I just read just now for trial 2. And then for trial 3, we will use the same cast iron, which is 75 length, breadth B is 9.5, depth D is 9.44, and depth of notch D is 4. And then we release the pendulum again. The hammer strike against the specimen, breaks it and swing further than the observation is noted down. So here we will see that total loss of energy during transit of hammer is ET equals to 7J, and then energy of failure of specimen is ET minus EF equals to 5J. So the observation that we got here is for trial 1, loss of energy due to friction EF is 2, and total loss of energy during transit of hammer is 4, and then energy for failure of specimen is 2. And then for trial 2, loss of energy is still same, but there's change in total loss of energy, which is it becomes 6, and then energy for failure specimen is 4. And then for trial 3, loss of energy is still the same, but total loss of energy is 7, and then energy for failure of specimen is 5. So average energy for failure of specimen is 3.67 joule.
The next part is mild steel. Length is 76.6 millimeters, breadth 9.42 millimeter, depth 9.4 millimeter, depth of notch 4 millimeter. Step 2. Test for friction loss in conductor by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. Loss of energy due to friction, EF equals 4 joule. The isot test specimen as per Indian Standard IS 3766-1977 is placed in position. The pendulum is released. The hammer strikes against the specimen, break it and swing further than the observation is noted down. The test piece was not broken by striking energy of the testing machine, so the impact value obtained is indefinite. Observation for trial 1. Initial energy of hammer is 164 joule. Average loss of energy due to friction, EF equals 4 joule. Total loss of energy, ET, during transit of hammer, indefinite. Energy for failure of specimen, KU, per impact value equals ET minus EF equals indefinite. Step 3. The isot test specimen as per Indian Standard IS 3766-1977 is placed in position. Trial 2. Length is 75.7 millimeters, breadth 9.54 millimeter, depth 9.6 millimeter, depth of notch 4 millimeters. The pendulum is released. The hammer strikes against the specimen, break it and swing further than the observation is noted down. Total loss of energy during transit of hammer, ET, equals by 44 joule. Energy for failure of specimen equals ET minus EF equals 40 joule. Observation. Initial energy of the hammer is 164 joule. Average loss of energy due to friction, EF, equals 4 joule. Total loss of energy, ET, during transit of a hammer equals 44 joule. Energy for failure of specimen equals KU per impact value equals ET minus EF equals 40 joule. The isot test specimen as per Indian Standard IS 3766-1977 is placed in position. Trial 3. Length 76.26 millimeter, breadth 9.32 millimeter, depth 9.48 millimeter, depth of notch 4.5 millimeter. Step 4. The pendulum is released. The hammer strikes against the specimens, breaks and swings further than the observation is noted down. Total loss of energy during transit of hammers, ET, equals 41 joule. Energy for failure of specimen, ET minus EF, equals 37 joule. The observation, trial 1, 2 and 3. Loss of energy due to friction, EF, joule. The trial 1 is 4, the trial 2 is 4, the trial 3, 4. Total loss of energy, ET, during transit of hammer, joule. Trial 2, 44 joule, trial 3, 41 joule. Next, energy for failure of specimen equals Ku per impact value equals Et minus Ef joule. Trial 2, 40 joule. Trial 3, 37 joule. Average energy for failure of specimen is 38.50 joule.